Alright, let's take a closer look at carbon capture and storage technologies. And I've subtitled this presentation, How to Stop the CO2 that we produce from reaching the atmosphere. Because that's really the goal of this entire process. So we're going to take a look at carbon capture and storage technology. What is it exactly? And you'll notice that it's very commonly short formed to CCS, which we'll do in a lot of this presentation. We'll take a quick look at the brief history of carbon capture and storage, as it is a relatively new technology. Then we'll take a look at how does CCS, what role does it play in a truly sustainable world? And we'll see how the main role is a solution now that can be implemented while other changes are still happening in our society. And all throughout this presentation, we will have the results of expert research, whether that be from, some are from governments that are playing a large role in this technology, some will be from scientists and not-for-profit organizations, but we're also going to see some implementations from some industrial or for-profit companies that are starting to really help control the amount of CO2 that they release to the atmosphere. So carbon capture and storage, what is it exactly? And it really is, there's three main parts to this technology, to this process. And the first part is that we need to capture the CO2 before it's released into the atmosphere. So at source, where it's being produced as a byproduct, typically by energy producers and large industrial processes like steel, cement, and fertilizer manufacturers, right, we need to capture it before it can get into the atmosphere. But then we need to transport it. And you can see we can do it in very conventional ways, above ground, below ground, and by sea. We'll take a look at some examples more specifically in a second. And then we've got the CO2, we need to use it or we need to store it. So even though we're going to focus mostly on storage in this presentation, there are products that use CO2. We can use it in the enhanced oil recovery process as well. But mostly we're going to look at onshore and offshore solutions for the storage. So why don't we take a quick, we're going to take about a minute to watch a quick video that really is an overview of this entire carbon capture and storage process. So let's take a look at that now.
Large amounts of CO2 are released when fossil fuels are burned at power plants or other industrial processes. This CO2 can be isolated and captured. Once separated, the CO2 is compressed and transported to a suitable geological storage site. These include depleted oil and gas fields or deep saline aquifers. The CO2 is injected into these formations. The cap rock prevents it from returning to the surface, and it becomes trapped within the pores of the rock. These sites have securely contained fluids and gases for millions of years, and with careful selection, they offer confidence in the integrity of CO2 storage.
All right, so CO2 capture. What does it look like? Here we can see that there's a power plant on the left, a fossil fuel burning power plant that takes oil, gas, or coal, converts it through a process into electricity, but it's creating this large amount of an unwanted byproduct called CO2. So that will get transported to a CO2 capture, separation, and compression plant, processed, and we'll see what happens after that. We can also see on the right, like we had mentioned before, that another large producer of excess CO2 are heavy industrial processes like steel creators, manufacturers, cement, and fertilizer manufacturers. So this is where we can get the CO2 from, or where it's being produced in excess. Let's see what we do next. So next we of course have to transport it. CO2 is transported from the capture location, either through onshore transport, such as above ground, maybe tanker trucks, rail. We can also build underground pipelines that can kind of get the CO2 out of the way. If it's done in a safe manner, that's very, very effective as well. But because CO2 as a gas can be compressed and actually be converted into its liquid form, it's very easy to transport by tanker, large tanker ships as well, and that way we can also transport them large distances to where they're going to ultimately be used or stored. So CO2 storage or use, again, we're just going to show a simple example here of the power plant in the middle producing CO2. Some can get fed off to the factory you see there on the left, which might produce carbonated drinks. But some could be used in that enhanced oil recovery process we had talked about to help pull the oil from the ground. But doing it in a closed loop will help mitigate as much as possible the environmental effects of that process. But on the right-hand side of the page, this is where we see the actual storage. So one example is onshore storage, as we had seen in the video. So I won't go into much more detail here because we've already seen that. But also offshore storage, and this is what we're going to take a little bit closer look when we look at a large-scale, one of the first large-scale industrial producers of energy. They actually use the offshore storage as the final spot for the CO2 to be stored. So what is the history of carbon capture and storage? Well, in 1989, the Carbon Capture and Sequestration Technologies program was actually implemented or founded at MIT, which is a large university in the United States. And here's just a quick excerpt from their website. So carbon sequestration, which just means a way to capture and store, to separate it, is a way to reduce greenhouse gas emissions. And what's neat is it really complements two other major approaches. So this isn't a solution by itself. It's really part of a group of solutions for greenhouse gas reduction, which is namely we need to improve our energy efficiency ultimately so we can get more production from less energy, especially when those come from carbon-based sources like fossil fuels. But long term, we really want to increase or switch over to non-carbon energy sources. So hopefully CCS is really a shorter term solution. And once we no longer are producing excess CO2, we can get rid of it. One of the reasons that also MIT has said that interest has grown so quickly is because it's very compatible with the large energy production and delivery infrastructure already in place. So even though there's an additional cost, it's mitigated by the fact that there's already some delivery systems in place, as we had seen earlier. Now, in 1991, there's really the first example of a government taking action, and it was the Norwegian government that instituted a tax on CO2 emissions. And that's what motivated Statoil, which was the largest oil and gas producer in Norway, to create the Sleipner project, which we'll take a quick look at here in a minute. What the government did is they effectively imposed a carbon tax of $50 per ton per CO2 released into the atmosphere. Right, so now there's a cost to the producer of CO2, and therefore there's a little bit of an incentive to say, well, maybe we can find or work with better solutions. And 5 years later, the Sleipner CCS project actually began operation, and it was the first of its kind in the world where a large-scale CCS project was located at source. One more notable thing that we'll look at in the history of CCS was the establishment of the Global CSS Institute. The headquarters are in Melbourne, Australia, but there's also regional offices in Washington, D.C., Brussels, Beijing, and Tokyo. So here's an overview of the Sleipner Carbon Capture and Storage project in Norway. It's located in the North Sea, which is 250 kilometers west of Norway, operated by Statoil, Norway's largest oil and gas company. And their main business is to produce natural gas and oil, which they've done for quite a while. But what they've done here when they implemented this carbon capture project is now 100% of the CO2 produced is actually captured and then stored in a deep saline aquifer. So again, deep just means located well under the ground. Saline is salt, and aquifer is the water or salt water that's found under the bedrock, under the ocean. So what's the role? The role of CCS in a sustainable world is that, again, this institution was formed out of a meeting on climate change on July 10th, 2009, where world leaders met, including the US President and the Australian Prime Minister. And here are some of the stats. This is what the experts tell us. 40% of CO2 emissions right now are generated from fossil fuel electricity generation projects. 25% of CO2 emissions are from large-scale industrial process, as we had talked about earlier. So 65% of CO2 emissions into the atmosphere really are from industrial processes that CCS is a great fit for. And with world energy demand only projected to grow by an additional 40+% over the next 20 years, implementation now is very, very important so that we can stop this effect we're having on climate change from the current production of CO2, but also the growth in production that will happen in the very, very short term. Right now there's 22 major CCS projects either operating or being built around the world, which have the capacity to capture 40 million tons of CO2 every year. And to put that in perspective, that's the same as taking 8 million cars off of our roads, and of course the CO2 that they would produce. In Canada, a little bit closer to home, here's some notable Canadian carbon capture operations. The Boundary Dam CCS project in Saskatchewan is a really interesting one. It's actually a project that became operational in 2014, and it was the world's first example of carbon capture and storage at full scale on a power station. Also in Saskatchewan, we have the Great Plains Synfuel plant and Weybourne Middale project, also in Saskatchewan, which captures, transports, and utilizes CO2. It's actually captured from the United States, transported to Canada, used in the Enhanced Oil Recovery Project, and then permanently stored underground. And nearly 30 million tons of CO2 have been stored there since 2000. And lastly, the Quest project in Alberta. The Quest project was launched recently in November 2015, and it will capture approximately 1 million tons of CO2 per year from the manufacture of hydrogen for upgrading bitumen in the oil sands projects into synthetic crude. And it's the example of North America's first large-scale CCS project to store CO2 exclusively in a deep saline formation. CCS technology as it currently stands allows for up to 90% of all CO2 listed above to be captured and stored safely. The next advancements really need to come from making this technology less expensive to implement, although we're well on our way to that as it stands now. So, in conclusion, this is a technology that's readily available, it's effective, and it's a way to capture most CO2 emissions. The cost of implementation must be reduced for full-scale implementation. Longer term, the best solution is a move to renewable energy production, but this does serve as a right-now solution to the CO2 emission problem that we have. One of the good things is that the cost of implementation is borne by the CO2 producers. Even if it's passed on to their users, the cost to implement it is going to be put in place by the companies that produce the most CO2. So in closing, here's some reference materials you could take a look at, some great information that goes into more detail. Thank you very much for watching this presentation. I hope you found it informative, and have a great day.